When coming to the demo, the project has been implemented in Java. So I'm interested in showing the project in Eclipse. So let's verify what exactly is inside the project. So as we have three types of models being implemented, the logistic regression and naive Bayes with and without feature selector. So we have three individual folders which consists of the code for three of those models, and there is a data set. The data set consists of the training data and the test data which is being available publicly. And so let's go through the training data. So these messages are the non-spam messages, so which just consists of the subject, date, and few other information. And let's verify the spam emails as well. So we can see the spam emails clearly. So these list of emails are used in training the model for our email spam filtration, and the test messages consists of the emails where we need to identify if the emails are spam or ham. So as part of the demo, I would like to start with logistic regression. So initially, logistic regression consists of classifier evaluator and the logistic regression classifier. So initially, let's go through the logistic regression classifier. So this class mainly consists of the training methods and the methods to read the spam and ham folders, the data sets. So when we go about starting to run the demo, initially we train our model with the so as we can see here, we are training the model with both the data sets of spam and non-spam messages. So let's jump into the train model. So here in these two methods, we are actually creating a a common data structure where we have both the spam and non-spam message keywords, and then we are identifying the weighted words by using the common data structure generated here, and then we are training the model by using the data set spam and non-spam data sets and identifying the likelihood of the spam and non-spam, both of them, and then finding out the new weights and updating the new weights. So let's quickly run this. And so after training the model, we are then going to using this model, we are going to classify all the emails which are present in the test data set. So let's have a look at the classify method. So this classify method, it basically uses the classify of logistic regression class, where we are using where we identify the messages, I mean the words which are present in the email, each email, and they compute the spam and ham probability. And after computing those probabilities, we compare if which one among those is bigger, and that decides what type of email it is. So let's just quickly run the logistic regression logic and see the results. So as we can see, the values being generated in terms of the accuracy, precision. So all the test messages are being evaluated, and here we are. So while classification, after identifying if an email is a spam or ham email, we are calculating the number of true positives and false negatives, and false positives and true negatives. So true positives are the values where we decided if at all email is a spam or ham. If it is a spam and by name we already know that it is a spam, then it is a true positive, meaning we identified it correctly. And if it contains spam and we stated that it is not a spam, then it is a false negative. In the similar way, we generate the count of false positives and true negatives. So this count, these four variables show the count of spam and non-spam messages which are correctly identified and incorrectly identified. Um, and these are used in calculating the accuracy. So the get accuracy method is used for calculating the accuracy by using the true positives and true negatives. So yeah, compute scores. So as part of the feature selection, we are also computing the scores in terms of the spam precision, spam F measure, and so these are the numbers which are calculated from the words count in terms of the spam and ham keywords, which would be useful in future. So as part of, so whenever we run the feature selector, um, we generate two files. um, we generate two files in the same folder, which consists of the spam and ham words separately. So let's look into that. Yeah, it seems that the spam and ham keywords are generated. So here, when we open the spam keywords file, so we can see all the ham keywords being identified and written into a file. So in the similar way, we have spam keywords also being generated. So these keywords are being used by the naive Bayes algorithm in future for spam filtration. So let's have a look at the naive Bayes algorithm. So the naive Bayes algorithm, as part of running the program, we initially check if we are selecting naive Bayes algorithm with feature selection or without feature selection. If we are choosing it with feature selection, it would choose the spam ham keywords and spam keywords which are generated as part of the feature selection we ran just now. So it's going to use these two um, text documents in order to train the model. So let's look into how this model is getting trained by using those two files being generated already. So loading ham keywords, this method basically iterates through all the ham keywords in this ham keywords text file, and then it makes a list of all those keywords. And then the next method as part of the training is load spam keywords. So in this load spam keywords method, we iterate through all the spam keywords, which is nothing but this text document, and we add them to the list. And let's go back to where we are. Okay, so train ham with keywords. So as we now have a list of all the spam and ham keywords being generated from the feature selection, we now generate a common feature repository data structure which consists of all the words, be it the spam or be it the ham words. We are keeping them under a common data structure. By using these two methods, we are doing that. We are basically generating a common data structure which holds both of them, and then by using the number of messages, so the number of ham messages and number of spam messages count, we are identifying the prior probabilities, which is nothing but the number of ham messages and the total number of messages and number of spam messages and the total number of messages. And then in the compute probabilities, we go ahead and create the evaluation criteria. So here, um, then we then iterate through all the keywords present in the common data structure and get the ham and spam frequency of all the keywords, and use keep summing them up, and it is ultimately used in finding out the um, totals total ham probability and spam probability. So this method here computes. Okay. So this method here computes the ham probability. So we are basically using the total count of the ham numbers and the total keywords we iterated through, and then using it. So getting back to where we are. So we are basically computing the spam and ham ultimate probabilities, which can be said as the evaluation criteria. So let's get back to the evaluation. So far we had a look at training the data set in case of a feature selection process, and then um, if we are not interested in using the keywords from the feature selection algorithm, then we train the data set in a little different way. um, so let's look at this. So in this process we iterate through all the files and we directly create a common data structure which where we put each word, and we also associate parameter which says if they are found in ham or spam. And in this way we train the data model we train the model, we then go for the classification. So as part of the classify, we iterate through all the files which are present in the test dataset. The dataset, all these emails are iterated through, and then we use the classify method where we are yeah so where we are actually computing. So here we can see where we are actually computing the posterior probabilities, which can be used in deciding if the message is a spam or a ham email. So in this way we compute the this is the logic behind the naive Bayes algorithm. So let's actually run them. And so right now I have evaluate as false, I'm just making it as true. So this whenever made as true, we are selecting the naive Bayes algorithm with feature selection. So let's go back and run with feature selection. um, So these are the results being generated in terms of accuracy and precision. So it's this similar way. Um, so we as part of the classification, we generate the counters where we maintain the count of true positives, false negatives, similar to what we did in logistic regression. And by using all these numbers, we generate the accuracy of this method. So by using the ratios of true positives plus true negatives by the total number of messages, we identify the accuracy of this method. In the so this is the method which we ran by using the feature selection. So let's run the same method without feature selection. Yes, and this takes a while as we are processing through each file and identifying if the words are spam or ham. But in the in the previous method where we use feature selection, we already had a list of spam and ham words. So here we can see the accuracy and precision. So in the similar way, here also we identify the false negatives and false positives and true negatives and true positives by which the accuracy can be found. So here we can see better results than the two methods which we did previously. So let's jump into the comparison of the results in a graphical terms.